Welcome to Brain Vision.
A steel casing weighing 2 grams has an initial temperature of 500 degrees Celsius and 70 kilograms of water is initially at 25 degrees Celsius. If the hot steel was placed into the cold water, what is the final temperature? And we are to ignore the effects of expansion or contraction and assume a constant specific heat of 4.18 kilojoules per kilogram degree C for water and 0.50 kilojoules per kilogram degree C for the steel. So here we're going to use our MCAT equations, and the Q for the steel has to equal the negative Q for the water, or the Q for the water has to equal the negative Q for the steel. So what we're going to do is we're going to put in our values to their respective MCAT equations. So for the steel, we have our mass of 2, our specific heat of 0.50, and our change in temperature. Now, delta T is always T final minus T initial. So we don't know our final, that's what we're looking for, but we have our initial, that's 500. This is going to equal negative, and then in parentheses, we're going to have 70 times 4.18 times T final minus 25. So let's simplify this mess down. We have 2 times 0.5. That's going to be 1 times TF minus 500. That's going to equal 70 times 4.18. And that would be negative. And then in our brackets, we have 292.6 T final minus 25, and one more bracket. So let's give us a little more room. So we have T final minus 500 is equal to negative 292.6 TF, and then plus our 292.6 times 25, that's going to be 7,315. So let's bring all of our TFs over to one side and everything else over to the other. So we're going to subtract 7,315 from both sides. And we're going to subtract 1 TF from both sides. So we're going to have negative 500 minus 7,315. That's going to be negative 7,815. That's going to equal negative 293.6 TF. TF, therefore, is just equal to negative 7,815 over 293.6. Don't forget that negative sign. And when we simplify this down, we find that it's 26.618 degrees Celsius. Let's round this to 26.6 degrees Celsius, and that is the final temperature.